So on a calculator, there's two kinds of logs you can compute. The first is a common log. So when you see the word log or the function log and there's no base denoted, that means the common log is being used, and the common log has a base 10. So for example, when we write log of 100 and we're wondering, well, what's that equal to? If you just go to your calculator and type in log of 100, you'll see an answer of 2. Why is that? Because what is log of 100 equal to? If we do what we were doing in the previous section and said, okay, I wonder what that's equal to, even though there's nothing written here as a base, it's understood that the base is 10. So 10 to what power is 100? Oh, that would be 10 to the second power. So log of 100 is equal to 2. Similarly, log of 1000 would be equal to -3. Why? Because if we're wondering, what is log of 1 over 1000 equal to? Again, the base is understood to be 10, so 10 to what power would give us 1 over 1000? Well, 10 to the third power would give us 1000, and to get the reciprocal, we would be using a negative power. Now notice we can't do that with log of 12. If we said, wonder what log of 12 is equal to, 10 to what power gives us 12, well, that's not going to be an integer answer. So that would be an example of when you type that into your calculator and you say log of 12, and your calculator gives you a value of 1.079, what that means is 10 to approximately the 1.079 power would give you something very close to 12. Now the other log on your calculator is what's called the natural log. And in the natural log, the base is understood to be the Euler constant E. To distinguish between the common log and the natural log, the abbreviation ln is used for the natural log. And so when we type something like, for example, natural log of 7, what we're asking is, natural log of 7 is equal to some number, and again, the base is understood to be e. E to what power would give us something very close to 7. So when you type in natural log of 7 on your calculator, and your calculator says the natural log of 7 is about equal to 1.95, what we're being told is if you took the Euler constant e and raised it to the 1.95 power, you get a number very close to 7. So your calculator does two types of logs, common logs, base 10, and natural logs, base e. Again, if you wanted to graph the log function, we would always use technology. Finding the domain of log functions. Remember, the domain of a log function, the domain is all positive numbers, so the domain would go from 0 to infinity. So if we're asked to find the domain of a log function, for example, find the domain of this log function, we would say, okay, we know that the log function, what we're taking the log of, must be greater than 0. So that would tell us that x minus 5 must be greater than 0. In other words, the domain has to be positive integers or positive numbers. And so the domain would be x is greater than 5. We'll try another one. Find the domain of this log function. Well, what we're taking the log of, 2x plus 4, must be greater than 0. And then if we just solve this, we'll find out that the domain are numbers which are greater than -2. So here's one for you to try. Find the domain of this log function.